Okay, an object is placed 10 centimeter in front of a concave mirror whose focal length is 15 centimeter. Determine the position of the image, the linear magnification, and state the properties of the image. Okay? Okay, good. So now let's look at this question. So what? Okay, is this mirror or lens? First you must identify, is it mirror or lens? This is a concave mirror. Okay, it's not lens, it's about mirror. Okay? Okay, so given here object distance, u, and then the focal length. Find the image distance. We need to find image distance. Okay, let's do question A first. I always like to draw the diagram first. I always like to draw the diagram first. Draw the diagram. Okay, I draw the principal axis first. Okay, so okay, object. Okay, this is the object over here. So concave mirror looks something like this. Oops. Yeah, this is the concave mirror. Concave towards the object. Okay, this is the concave mirror. Okay, so now once you draw this, I want you to first draw the incident ray and reflected ray. This is the most important. Draw the incident ray and reflected ray. Incident ray, the light comes from the object. This is the incident ray. And then you have, because this is a mirror, okay, because it's a mirror, the light is reflected. The light cannot pass through. That's why you must identify first, is this mirror or lens? If lens, the light penetrate, go to the other side. But if mirror, the light is reflected to the same side. That's why there's the difference between mirror and lens. For lens, the light pass through. For mirror, the light cannot pass through, is reflected. So this refracted ray or reflected ray is very, very important. This is very, very important. So you must first identify, is it lens or mirror? Okay. So okay, let me go back to here. So the this mirror, the light should be reflected, not refracted. It should be reflected. Reflected ray. Okay, or reflected lah ray. Okay. So alright. So this object distance should be positive or negative. Remember our rules. Back to our rules. Sorry, our rules. Object always compare with incident ray. The rest, like image, focal length, and radius, compare with reflected ray. This is the comparison partner. Okay. Okay, I want to write it over here. Compare. Object always compare with incident ray. Okay. And then incident, the V, the focal length, the radius, all compare with reflected ray. Okay. Right. If same side, then the sign should be positive, or is real lah. It's real. If opposite side, then it must be negative. It must be virtual. Okay. I want to highlight this. Put it like this. Okay. Put it like this. Understand? Same side is real, opposite side is virtual, negative, virtual. All right. Okay. So now, okay. So this object is 10 cm, should be positive lah, because object is same side as the incident ray. Okay, write that down. I want to write that, maybe this one. Yeah, this is the object distance, u, same side with incident ray, so this 10 cm should be positive. Okay, and then how about the focal length? Because it tell you the concave mirror, this is a concave mirror, so this focal length should be positive or negative. So look at this concave mirror. So this concave mirror, where is the radius? Where is the radius, or where is the center of curvature? If you still remember, I told you about this. For a second, this one. Still remember? Radius of curvature also compare with the outgoing light. If the center curvature is same side as the outgoing light, radius of focal length same side as the outgoing light, the radius should be positive. Okay, that's the rule. Go back to that question. Yeah. So this focal length or radius of curvature, yeah, we can say this is the focal length, or we can take this as the focal length. This one focal length also refer to the radius, also refer to the center of curvature. Yeah. So look at this surface, concave mirror, this surface. Okay, look at this surface. Where do you think is the center of curvature? Center curvature should be over here. Center curvature, isn't it? Because this one is curving to this side, curving to the left hand side. So the center curvature should be here. So the radius should be over here. This is the radius. This is the radius, isn't it? And then the focal length, maybe it's over here. This is a focal point. Then the focal length should be this side, this one. Okay. So this radius and the focal length, it is focal length and focal length and radius compare with reflected ray. Compare with reflected ray. So if same side is positive, so this radius and focal length, they are at the same side with the reflected ray. So this radius and focal length should be positive. Should be positive. Understand? So that's why concave mirror, the radius and focal length is positive. Positive because it is same side as the reflected ray. Okay, same side as the reflected ray. So this 15 cm you should put as positive 15. Okay, let me write down just now the object distance is positive 10. And then this focal length should be positive 15. Positive 15. Why positive 15? Because it is why focal length is positive? Because it is same side as the reflected ray. Understand? Okay. Or we can also write the radius is positive. R is 2f. R is 2f, so is positive 30 centimeter as well. The radius also positive. Okay. Now, okay, want to find the position of image. That means the image distance. Okay, image distance. So what formula we use for mirror? Okay, for mirror we're going to use the mirror equation, 1 over u plus 1 over v equal to 1 over f. Okay, so let me use that formula. Question A, 1 over u plus 1 over v equal to 1 over f. So, okay, the object distance is positive 10 centimeter. I need to write the centimeter here because you need to write the unit with the value. Because this is not meter, this is not SI unit. If not SI unit, you need to write the unit together with the value. Okay. And then image distance and focal length is also positive, positive and 15. Why is the focal length positive? Because the focal length is same side as the reflected ray, so that's why it's positive, positive 15. Okay, so now V, let's calculate the V. So V 1 over 15, and then minus 1 over 10, and then answer, and then okay, so you get the V is V, okay, inverted. Remember, you need to take the reciprocal, take the reciprocal, because the answer you get is just 1 over V, the answer you get is just 1 over V, negative 1 over 30. So you need to take the reciprocal, I need to take the reciprocal, take the reciprocal. Take the reciprocal, that means you need to invert it, you need to negative this one, take the reciprocal. So take reciprocal, so it become what's the answer? Negative V is negative 30, negative 30 centimeter. Okay, so I got negative image distance. So this is a real or virtual image? This is a virtual image. So this is a virtual image. So this negative V, So first of all, I want to ask you, where is this form? If you want you to draw on the diagram, where is the virtual image form? Where is it formed? This V is negative. If V is negative, means it is formed. V we compare with who? V focal length and radius all compare with reflected ray. Understand? Compare with reflected ray. That's why you must first draw the incident ray and reflected ray. Very important. For us to compare with, like incident, we compare with object distance. Like reflected ray, we compare with the rest, the image distance, focal length, and radius. Right now, I want you to determine the position of the image. Is it formed in front of the mirror, or is it formed at the back of the mirror? Is it formed at the front, or is it formed at the back of mirror? And how do you know? How do you know where's the image form? Compare the image distance with the reflected ray. Compare with reflected ray. So since you get negative, means it is not at the same side with reflected ray. It must be formed at the opposite side of the reflected ray, not at the same side of reflected ray. That means it must be formed at the back of the mirror. It must be formed at the back of the mirror. Okay, it must be formed at the back of the mirror. So I can draw it over here. Formed at the back of the mirror. It's formed over here. And why I know is it upright? It's not. Why I didn't draw is inverted. Why it's not inverted? And why is it upright? Why is it upright image and not inverted image? Remember what I told you about this RIVU? About the image characteristics. If inverted image, just now you RIVU. So just now you got virtual image, right? Just now you got virtual image, right? Virtual image must be upright. And then another thing is, because why? Because you get V negative. Because you get V negative. So that's why it must be upright image. That's why I draw the image upright, not inverted. Inverted is for real image. Unless you get the V is positive. Unless you get V is positive, you get the real image. Okay, where the V is positive, then it is inverted image. Then it is inverted image. Understand? So Another thing I can elaborate, inverted image will have magnification negative, height of image negative. But if upright image, the magnification is positive, height of image is positive. But this is the rest lah, other notes lah. Okay. All right. Just want to put this in the table, yeah, for you to refer. Very important. I always repeat this over and over again. Virtual image must be upright. So it must be upright. Okay, so this one is correct. Must be virtual image must be VU. So it must be upright image. Okay, VU, virtual upright. Virtual upright. Okay, VU must be upright image. Okay, so this one. Okay, virtual. So now I want to find what? I want to find, so it's formed at the back here, formed at the opposite side of reflected ray, because they're not at the same side, because your V is negative. Okay, let me write it. Your V is negative. Negative 30 centimeter. Yeah, because your V is negative means the image is not at the same side with reflected ray. Yeah, compare with reflected ray. The image always compare with who? Image always compare with reflected ray. So not at the same side with the reflected ray. So that's why the V is negative. Okay. So okay, why this is a virtual image, means the reflected ray seems to originate from the image. Still remember the definition I tell you about the concept of virtual image? For virtual image, the light doesn't pass through the image point but appears to come from there, come from the image, come from the virtual image. That's what means by virtual image. It appears to come, the light come from there, come from the image. So you look back to my example here. This reflected light appears to come from the image. Appears to come from, the light doesn't go to that point. It doesn't pass through the image. But this reflected light appears to come from this image. That's why this is a virtual image. That's why the V is negative. Understand? That's why the V is negative. Okay. Now I want to find, I got the answer already, negative 30. Is the answer correct? Yes, the image distance is negative 30 cm. It's correct. It's correct. Now it's a virtual image. So now find B, magnification. Find B. Question B, magnification. Magnification is height of image over height of object, or we can use the other formula, negative image distance over object distance. Okay, so I think we use this one, negative V over U, because we have the V and U. We don't have the height of image or height of object. We use the formula negative V over U. Remember, height HIOHO no negative, but V over U got negative. Okay, the formula. So here you negative. This negative is from formula. This negative is from formula. The V itself got their own negative. That one you need to put another negative. Another negative, because the image is a virtual image. So it's different. Okay, it's different now, because this V is from this V is this negative is from formula. Negative from formula. This negative is the virtual image. It means virtual image. So it's different. This negative is from formula. This negative is from the characteristic of image, which is virtual. Understand? So different. Don't say that, oh, the formula got negative already, then this V no need to put negative. Wrong. Wrong, yeah? V got their own negative if it is a virtual image. Okay, and then U is the object distance, positive 10 centimeter. Write that down, yeah? Positive 10 centimeter. Okay, should put an centimeter like that, yeah? Okay, so now negative become positive. Negative become positive. So 30 divided by 10, you get 3. You get 3. So magnification is positive 3. So what does it mean by this positive 3? So remember what I tell you, what I tell you before. What does it mean by positive value, positive magnification? Positive magnification. Positive magnification means positive value means what? M positive means what? When the M is positive means what? Is it means magnified? No. M positive means it is upright. So it is upright. It is upright. This image is an upright image. Understand? That's why you see. Just now I predicted you get a V negative. V negative is virtual image. Virtual image means VU. VU is upright image. That's why the M is negative. M is positive. So you see, I predicted correctly. I got V negative. I got V negative. Oops, sorry. I got V negative means it is virtual image. It is virtual image. V negative. So VU, according to VU, when virtual image, it is also an upright image. When it is an upright image, so the magnification should get positive M. I should get positive M. And when positive M, the height of image also positive. So and I further calculate, I did get the magnification also positive. So my prediction is correct. The magnification, it should be a positive value. Why positive value? Because it is an upright image. Upright image should get a positive M. Okay? And is it a magnified or diminished image? Look at the value here. The value here. The value here is showing that the M is more than 1. Or we can say the modulus, the magnitude of M is more than 1. More than 1. So go back to my notes. Yeah. Okay, didn't say. Okay, if the value of M is more than 1, the magnitude of M is more than 1. Okay, then it is a magnified. It's magnified image. That means it's a magnified, or we say bigger image, bigger size image. Understand? So like for this value is M equal to 3, it means it's magnified. If you get M equal to, let's say, positive 0.3, this one, then this one is diminished because the, because this value, the value of M is less than 1, then this one is diminished image. Understand? Okay, so this is a magnified image because the value is more than 1. Okay, bigger image. Okay. So okay, now the answer, what's the linear magnification? Is positive 3. Yeah, positive 3. Is it correct? Yeah, 3. That's correct. Yeah, my answer is correct. So it's correct. My answer is correct. So positive 3. And then what is the properties of image? Okay, so what's the properties? So the properties of image is number 1, virtual image. Look at here, it is a virtual image. Why virtual image? Because you have V negative, okay, and then it is an also upright image. Yeah, upright image because M is positive. Because M is positive, and also virtual image is also upright image lah. When virtual image is always upright image. Okay, I get M positive value means the image is upright lah. Also, yeah. And I get M, the value is more than 1, so it's magnified. Magnified image, bigger image. So these three characteristics. At least 3, yeah. If ask you to find properties, you must give at least 3, yeah. Three properties, not just 2 properties. You must give at least 3 properties. So it's a virtual image. Virtual image. It is an upright image. It is a magnified image. Okay. Why virtual? Because the V is negative. Why upright? Because the magnification is positive value. Why magnified? Because the value of the magnitude of M is more than 1. Understand? So this is considered as the acronym of VUM. VUM, virtual upright magnified. So why is it producing virtual upright magnified image? If you look at the object distance compared with focal length, okay, compare with focal length, the object distance is, let me write it down. Let me write it down. The object distance is positive 10 centimeter. The focal length is positive 15 centimeter, and the radius is positive 30 centimeter. So where is the object? Oh, actually is the focal length the focal point should be more than the object. So I draw wrongly. Actually, this one should draw. You should draw it. The focal point should be over here. The focal point is over here. The center curvature is further down. Yeah. Focal point is maybe over here. This is a focal point. So that's why. Okay, let me draw again. This one, the focal length is over here. The F is positive because it's same side as the reflected ray. Okay, and then here you have the radius, the center curvature over here. This is the center curvature. The R also positive lah. Like that. So the U actually, the object distance actually is less than focal length. Yeah, the object is less than focal length. Should be here. That's why you get VUM. Yeah, virtual upright magnified image. You get a VUM image. Understand? So if you look at here, this U is less than F. If you go back to our characteristics of image, look at here. This is a concave mirror, right? This is a concave mirror. Concave mirror is a converging mirror. So you see the object 5 over here. Look at the object 5 over here. Object 5 over here. So it's less than the focal length. Less than the focal length. I mean, smaller than focal length. This object 5 produced the image 5, which is VUM. Predicted correctly. Tally with our calculation. Virtual upright magnified. So it is object 5 over here, less than focal length. The U less than focal length. So when the U less than focal length, indeed it produces virtual upright magnified image. So which is tally with our whole calculation here. You see that? So You see, 10 cm, the U 10 cm less than 15 cm focal length. U less than F. So when U less than F, you get a virtual upright magnified image. Virtual upright magnified image. Okay, so that's all for these questions. I hope you understand, okay, stay tuned for the next video. Bye.